Okay guys, welcome back to my channel. Now in the last video we discussed about the concept behind writing fast and beautiful code. Okay, now in this video we are going to look at the first point, and remember we said there are a couple of ways you can use in writing beautiful code. That's first, you shouldn't think of that shouldn't be your number one priority. Your priority there is going to be you writing a code that is going to do the job. Okay, once you've written the code that is doing the job, then you can come back and start doing some cleaning by trying to reduce the amount of lines, trying to optimize the code. And we're asking, how can we optimize this code? So the first point we have there is by using built-in functions and libraries. Okay, most times you want to write a program, and then um, maybe you don't know there is a built-in function for what you're trying to implement, or there is a library that you can just call in for what you're trying to implement, and then you try to reinvent the wheel. Now this is going to take you a whole lot of time, and possibly whatever you write, whatever code you write there is not going to be optimized. Think of it, when it comes to Python is built with C++. Okay, so they have a lot of inbuilt functions. They have a lot of libraries that are written in C++. Now, C++ is a language that is very fast, okay? Very fast compared to Python. So, almost all the inbuilt functions that are built with C++ for Python, they are optimized. Okay, this is something different programmers have already worked on over the years, and they've seen a way they can possibly reduce the amount of time it will take these functions to run, or these libraries to be used. So instead of you going ahead to try to create something new, why not use what you know is working and has been optimized? Okay, let me give you a simple example. So we just move down to our ID and see the example. So a simple example is you trying to create um, a function that is going to make counts of how many times items occurs in a particular iterable, maybe a list or a tuple. For example, I have a list of colors, so let's call them colors, and I have different colors there. I have blue, or let me not even use colors as an example so that I will not waste time typing these colors. I'm very slow at typing. So let's say we have numbers. We have a list of numbers, and I have these numbers. So I want to know how many times each of these number occurs in this list. So one thing we could do is create a function that's going to do the job. So I can call the function my count. So this function is going to do the job, and it's going to take in the array or the iterable. And then first what I'm going to do is I will use a dictionary. That's a data structure. I'm going to use a dictionary to keep count of how many times each of these things I have here occur. Okay. Initially, the key is going to be each of the values, the distinct values I have here, and then the values are going to be 0. I'm going to initialize all the values to be 0, saying okay, I've not counted any of these, or they all occur 0 times. Then I'll run through this loop, run through this array, and see how many times each item occurs. For any item I encounter, I will increase the count by 1. Any item I encounter, I will increase the value of that expression by 1. That's what we are going to do. Okay, now for us to initialize everything we have here, a good way would be to use a dictionary comprehension. So I'm going to say the key should be x, the value should be 0. This dictionary comprehension I'm using. For key, that's for x is going to be a number, or in this case an array, since that's what I call it. For x in array, So I'm saying pick every item you have in this array, make the key to be that item, and then make the value to be 0. This is what you call dictionary comprehension. You're doing something that you would have used a for loop, and you're doing it in one line. So I'm going to call this counts, store it in a variable called counts, and let's see what this will give to us. So let me just print count first and confirm what that would be. So let's test the function, my counts, and I'll pass in numbers, and let's see what we have there. And that's taking time. Okay, this is even taking too much time to run. It's still trying to run. Okay, so what we're going to do is, I think my kernel, they're saying there is no kernel. I just need to restart my kernel for this to work. So hold on guys, let me okay, I think it's working. Let's see. So let's run this, and then okay, so this is what we have. They said 3 is occurring 0 times 4, 0 times 5, and the rest of that. Now one other thing we could do is, instead of using array, is to transform this to a set. But there is no need transforming this to sets, because I think the time it will take to run through a set is far greater than the time it will take to run through a list. If not, I would have transformed this to a set so that each item is going to occur just once. Okay, so that's for that part. Now next, what we are going to do is to increment each of the value I have here by 1 based on the occurrence I have, which means I'll say for every element in number, pick that element, make it the key of count rather. So that's, I'm saying this count should have the key to be that element, then increment the value by 1, because once I encounter that key again, it means yes, there's another occurrence. So I'm going to increment the value from being 0 to be 1. I encounter it again, it will become 2. Anyone I encounter, I'll keep on increasing the value. Okay, so now let's run this and see what this will give to us. So it's saying 3 occurs once, 4 occurs 4 times, 5 occurs 6 times, 6 occurs 6 times, 35 occurs once, 78, and 8 occurs 3 times. Now that's what we have in this list. So this is going to do the work for us, trying to keep count of the number of occurrence of each item in this list. But you can see we trying to implement this has taken away the main idea. The main idea, maybe we are creating a software, so we've gone beyond the business. Now we are going to look at the implementation of some low level details, which is not actually what we want. We don't want to spend our time doing this, so why not just use an inbuilt function instead of doing this? So how do we use an inbuilt function? And this is why it is a good idea for you to always go through the documentation of any programming language you're working with. The documentations are always going to point you to the right direction, the kind of functions you have available, the external libraries you have available, and the rest of that. It's always a good idea to go to the documentations. So here we have, this is not actually an inbuilt function, okay? It is a library that we need to import and make use of. So there is this library in Python that we call the collection library, or the collections model. So within the collection models, there is a function called counter. So instead of me writing this code, all that I would have done is to call counter and then passing this as the argument. So let's see what's given to us, and that's the result. The same thing we have here: 3 occurring once, 4 is occurring 4 times, 5 is occurring 6 times, and the rest of that. Okay, so this is far too Pythonic compared to this. Though when you're doing this, you'll be feeling like, okay, you're creating something nice and the rest of that, but try not to do that. Okay, try to focus on the business and forget about you trying to reinvent the wheel. So that's the reason this will be preferred compared to this. Okay, so that's the first illustration of you trying to use inbuilt functions instead of trying to reinvent the wheel. Now the second thing we are going to look at, another example we are going to look at here, is um, you trying to create a cipher, to be precise a shift cipher. Now this is what the shift cipher is. Let's say you're trying to send in a message, a secret message, and then you send a message that has just, let's say, come. Now you want to encrypt this message in such a way that you want to shift each letter either to the left or to the right, okay, by some characters, from some number of characters. So let's say I want to shift this by 3. So I already have A, B, C, D, E, F, for example. Anywhere I see C, I'm going to replace C by, let's shift it by 3. So I have 1, 2, 3. So I'm going to replace C by F. In place of O, I'll replace it by, if we shift that, let's just have all the alphabets here. Now there's an easy way to get in all the alphabets. Okay, let me show you how I can get in all the alphabets instead of typing that out. So first I'm going to comment this. For you to get in all the alphabets, there is a model called strings. Okay, so I'm going to import strings. Then within string, I'll look for ASCII letters. Let's use the lowercase letters, and that's going to give you all the alphabet from A to Z. So instead of anywhere I see C, is going to be replaced with F. Anywhere there is O, it will replace with that should be R. Wherever there is M, M will be replaced with, that should be P, and the rest of that. So that's the shift cipher. So you can shift it by any degree of characters you want. Okay, so let's say you want to write a program that is going to do this. First thing you're going to do, let's call the function shift cipher. Okay, and it's going to take in a sentence. Then we want to convert the sentence to a code that nobody understands, just you. Now it is possible to decrypt this cipher by shifting it. If you shifted it to the right by 3, then to decrypt it, you shift it to the left by 3. That's going to decrypt this cipher. Okay, but let's get on with this. So one thing we could do is to first, let's still use our dictionary comprehension. I would like to say I want to know the position of each of these characters, so that if I'm shifting by 3, all I need to do is, since I know the position, I'll just take that position, increment it by 3, and then pick the item I have there. So what I mean by that is this: I can say A is having a position 1, and B is having a position 2, C is having a position 3, C is having a position 3, and this is still another case we don't want, because I'm trying to do this, I have to do this, I think that should be 26 times. So here also I don't want to reinvent this, so instead of me doing this, what I can possibly do is to use another function that is called the zip function. I can still use that function to create a dictionary comprehension. What I can do is to say, okay, I have X column Y. So X is going to be the key, which are the alphabet. Y is going to be the number, okay, which is going to be from 1 to 26. So I'll say X column Y. For X comma Y in zip of I'm going to pick this in zip of this comma range of 27. Now what am I trying to do? The zip function pairs elements, elements you have in iterable. So it's going to pick A, pair to the first value here, which in this case is going to be a 1. It will pick B, pair to a 2, pick C, pair to a 3, up to picking Z, and then to pair that to 26. Remember, you can get to 27. That's why I made it 27 based on the range function. So this is what we have first. This is going to be, let's call that the codes. Okay, and let's print out these codes and see if it's actually making sense. So I can call the shift cipher and then pass in a sentence. Right now it doesn't matter what I pass in, it's going to, okay, so I have A to be 1, B to be 2, down to Z being 26. So far this part is working. So let's come back and optimize this or complete the code. So what we want here is this: when we have this sentence, we want to create our result or our cipher text, because that's generally what we call it. We want to create a cipher text. So what the cipher text is going to be, initially is going to be empty. Okay, now I'll run through this part here. I'll say for each letter, or let's say each character, because possibly other characters can come in. For each character in codes or in sentence, pick that character, which is this. Now I need to know the position of this character. So the question is, how do we tell the position of this character? It's as simple as we wrapping that character as the index of codes, because remember, each of the character you have here could be A, B, C, D or so, and for codes we have it that A is the key, the position becomes 1, B is the key, the position which is the value becomes 2. So that's what this is going to do for us. Okay, but when we have this character, we want to increment it by 3. After incrementing it by 3, then return whatever we are going to have. So if I increment A by 3, I'm going to get a 4. So I have a 4, so it means I want to return D. So now we still have the question, how do we get back D? So if I want to get back D, I'm supposed to use an if condition to return the key where the value is equal to this. Okay, so what I mean by that is this. So I'm going to have this, I'll store it as the new position. After storing it at the new position, I'll have the value there, or the new character. Let's call it new character. The new character is going to be equal to whatever takes this value as the value. Okay, so I'll say, for still using the zip for the what's it called? Okay, now I'm not going to use a zip function. What I'm going to use is to unpack it. So I'm going to say for key comma value, let's say key comma value in codes dot item. So this is going to pick a tuple. It's going to give us a tuple, the first value being the key, the second value being the value. So if the value is equal to this position I have here, wherever the value is equal to that position, return the key of that. So if the value is equal to the position, our new character is going to be the key we have there. Okay, so the new character is going to be the key. So if the new character is the key, what are we going to do with this key now? What we are meant to do with this key is just to use it to increment the ciphertext. Okay, so what I mean by that is this. I'll have the ciphertext, which is a string, and then I'll concatenate it. I'm going to say it should be the old value plus the new character. That's what we have. And once this thing is satisfied, I'm meant to break out of the loop because I've gotten a condition that is satisfied. Then since I'm breaking out of the loop, this will become my expression. So let's print this ciphertext to see what it's going to look like now instead of printing the key. So I'll run this. Let's pass in BB as an example, because if we pass in BB, 5 is going to be E, so we are expecting EE to be our result. Okay, that works. So let's say BAD, we're expecting our result to be EDG. Is that correct? Let's find out if that's correct. So for us to find out, let's print codes again and try that. So we have BAD, B is a 5, that's A is going to be a D, then D, adding 3 to this, that's going to be a G. So that's correct. So the cipher is actually working. So if I pass in a sentence like or let's say just a word, let's put in my name, it's not seeing S. That's one of the issue we have. Okay, it's not going to see capital S because I didn't implement capital S here. Okay, the uppercase of it is not seen here. So what I'm supposed to do to take care of this issue is to reduce everything that comes in to lowercase. So I'm going to take sentence and reduce it to lowercase. So I'll say sentence should be equal to sentence dot lower. So that's going to take care of that issue. But is that wise? Let's confirm that again. So now that's working. Okay, but now this is much code, and there's a way we can optimize this function. How can we optimize this function? We can optimize this function by using some other inbuilt function. So let me show you the inbuilt functions we are going to use. One of them is called the char. The char takes a number and then return. This is a decimal. It takes a number in base 10 basically, and then return the ASCII character in that position. So 97 is actually A, so you can guess it that 98 is a B, and then 100 is going to be a D. So that's a char. Then we have another function that does the reverse. Okay, it is called the order, the odd. So if I give it A, it's going to return the value of A, which is 97, the decimal value in terms of ASCII code of A. If I give it something like 200, or let me use 70. So I said 70. Let me give it capital A. It's 65. Okay, that's the value we have. So basically, lower cases are having higher values compared to upper cases. So that's why you have A to be 97, and then capital letter A or uppercase A is giving us 65. So this is what I'm going to use now. So the char and the other function, they are the ones I'm going to use. So how do I make use of this? So all I need to do to modify this code here is simply this. Now, before I even modify this code, I could do something. There's a way I can even reduce this line of code here. Okay, this is how I can reduce this line of code. Let's do that first, then I'll show you how to use a child eval. So to reduce this line of code, what I could possibly do, instead of looping through this, I'm going to create another one, another dictionary comprehension, but this is going to be the reverse. So I'll call it codes reverse. And what it's going to do here is this. The key here are the alphabets, the values are the numbers, but now I want to change that. I want the values to be the alphabet and the keys to be the numbers. So what I could simply do is to say I also have x comma y, or x column y, for x comma y, but since I want to reverse it, I'll say for y comma x in codes dot items. So once I do this, I don't need this for loop any longer. Okay, the only thing I need here is this guy. I don't need this other for loop, so I'm going to remove this for loop. Okay, that's a great reduction. Then I'll take this position, make it the key of cipher reversed. Okay, and that is still going to do the work. Let's confirm this. So let's say shift cipher. Let's make this one 1 so that we'll know we are talking about a different implementation. So 1, and let's pass in Smith. You can see that still works, but still this is large amount of codes that we still want to reduce. So if I want to reduce this, all I can possibly do is okay, all I can possibly do is I'm going to remove these 2 lines of code. I don't need them. And I'm going to even I think I can even take away this. I can take away everything here. Let me just remove everything and let's start this thing afresh. So what I'm going to do is I want to use list comprehension. Took away everything. So what we're going to do, in fact, I want everything to be in less than 4 lines of code. That's the kind of optimization I want to do, instead of we having this bulk we have here, or even this one we have here. So how do I make it to be in less than 4 lines of code? Number 1, I'll use list comprehension. So each item I have here, each element I have here, I want to take the order. So if I take the order, remember the order is going to tell me the value where that is stored in the ASCII code for that. For that, if I have A, he's going to give me 97 in lowercase a. Uppercase A is going to give me 65. So I'll take the order of X. But once I've gotten the order of X, I'm supposed to, according to what it said, increment it by 3. So I'm shifting it by 3. After shifting it by 3, for example, if I take A, order of A is going to be 97. Increase it by 3, I'll get 100. Now I want to get the alphabet or the character in that position 100, or that is having the decimal representation to be 100. And remember from what we did up there, for you to do that, you have to use a char. Okay, the char is what's going to give you that. and that's what I have. But now I need to tell them where x is coming from. So I'll say for x in sentence. So this is going to give you a list of all the characters, but I want to take this list of all characters and then join it. I want to join it by nothing. Okay, I'll join everything there with nothing and then save the results in ciphertext. Well, I was saying less than 4 lines of code, so yeah, this less than 4 lines because this is just 2 lines of code, and we're done. So instead of we printing this time around, let's return. Okay, so let's see, change this to cipher 2, and then let's try our shift cipher 2 and see if it's going to work. Moment of truth. Okay, that works. Now notice the difference between this and the other implementation. This is actually keeping the case of each character. This, it reduced it to small letter v because of what we did there, but this is keeping the capital letter V we have. If we want this our own implementation to keep the case, then it means we have to increase our implementation here. We have to add more lines of code to take care of that, and that's not what we want to do. Now one other thing is, unlike this our implementation that is going to assume that all you're passing in are just containing alphabets, this implementation we have here is generalized. Okay, because these are coming from the ASCII code, and in ASCII code they have about I think more than 255 characters. Okay, our implementation is having just 26 characters. This is having up to 255 characters. So even if I pass in, I take in this shift cipher 2, and then I pass in something like this is the best example ever, and it's going to give me this as a result. It has converted all we have here to this. Okay, but now what if I want, let's say you sent this message to a friend, you encrypted it, and then the message, your friend received this. Your friend wants to transform this back to know what you actually sent to him. How is he going to do that? So that's where we are going to use a decryption algorithm. So I'm going to call it shift cipher decrypt. No need for the 2 here. So that's going to be, and here instead of us incrementing it by 3, we are going to reduce it by 3, and that's all we need there. So let's confirm that. So shift cipher decrypts. So let's pass in this is the message we want to pass in. Let's pass in this message and see if it's going to return this is the best example ever. Wow, that worked out. Okay, so let's try another one. So let's say shift cipher 2. Let's say I'm coming home with exclamation marks, and it's going to give us this as a result. So let's try to decrypt that. So we decrypt that, so we pass in this, and then we have I'm coming home as a result. So that's it guys for this point. So in the next video I'm going to show us another point. So this point we use there is, we shouldn't always try to reinvent the wheel. We should use what they have in store for us. And how do we know what they have in stock for us? Is by going through the documentation and different materials to see what they have. So that's why we could reduce this line of code to just 2 lines of code. Yeah, Okay, and that's a great implementation. Even if you go ahead and try to look for how long it will take this code to run, I think it's going to be drastically reduced. So from the next point, I'm going to be showing us how we can be testing for the time it's going to take our functions to run. Okay, so as always, go ahead and like the video if it helped you in any way. Subscribe to my channel. If you have any comments, any complaint, put it in the comment section below, and I'll see you guys in the next video. Bye bye.